Good afternoon, everybody, and welcome to this Net Zero Roundtable. It's the last roundtable of WEM this year. We're very lucky to have a plethora of experts on our panel, where we're going to basically be discussing an open fireside chat over the next 3 or 4 days on how we can use monitoring to help us towards that target of net zero. I think it's, if you're not aware of the target of 2050 for net zero, a lot of companies have said 2030. And I think it can be quite worrying that 2030 is, 9 years away, even 8 years away. And there's a huge amount to do. And really, the question is, how do we get there? We've seen over the past few months, a lot of the water companies publish this is our path to net zero. A lot of it functions, a lot of it centers around reducing energy, producing more energy production, producing resources. But a lot of the water companies will say, but there's still a gap there. And we don't know how we're going to fill that gap. Probably the subject today is, what can we do? How can we help? There's various ways of doing things, various ways of achieving things. So I'm going to open this up to the panel. I'm going to go to the first person at random. And my first question I'm going to ask the panel to introduce themselves. I'm going to ask them, what one thing do you think we could do today to help us towards net zero? So, Peniel, do you want to start?
Yeah, and I was allowed to share some presentation or just one slide, right?
Yep, perfect, yep.
Because you just said that to me 5 minutes ago, so I just translated
no rules.
Danish. Just have to find our share screen. Yeah, I think for me this illustration is very, very interesting, saying something which would be a hypothesis of where we are today. So what it sort of explains is that we have had a lot of good time with industrialization for a long while, and since the 1970s, sustainability has steadily increased. And this is from a Danish professor, and his hypothesis, which I think, at least in Denmark, is correct, is that here with the COVID crisis around 2020, we sort of get into to a breaking point where you have the sustainability and the industrial mindset being more or less equal, and industrialization disappearing, while sustainability is not just a nice trend. It's really that's sort of the focal point of the future of our society. So I think that explains a lot about what kind of difficulties are we in right now, because you have sort of these two mindsets, and they are close to equally strong. And am I going to make my arguments in the one kind of mind world or in the other mind world? So I think we are in a very interesting point right now. And this figure, and nobody knows if it's true, but it also gives me some kind of hope that we are actually at a point that now, I was born in 1971, so I was born more or less when sustainability started. I'll be 50 this year, and these 50 years and all the time I remember we have been discussing sustainability. And when I was young, it was sort of an interesting opportunity. And now sort of the heat has gone up until today, where I think the heat is really on, also with the thing you say, Oliver, then in 8 and 9 years, something like that. That's where we have to end. If we're going to continue our consumption as we are today, 9 years, we have to finish that. And that's really a very, very short time horizon. And in Denmark and in the city I work, we are working very, very hard on trying to find ways to become energy neutral. Everybody by 2030, that's the goal for the whole business. Everybody have to be neutral within that time frame. And when I heard that first, I thought, "Whoa, that's ambitious! And how are we going to achieve that?" But it's not even ambitious. That's actually the latest we can become energy neutral. So I think things are very, very urgent. And it's a very, very complex situation that we are looking into, also because we have these two mindsets sort of rubbing up against each other. So for me, what really works is that you continue making small changes, becoming wiser, getting a better overview, being more digital about your energy consumption. Where are we losing energy? Where are we losing CO2 equivalents? Also, is it nitrous oxide? Is that really the gas that is important to focus us on? So really getting very, very sharp on what are the sources that we really need to address. And there, I think the digital revolution is actually more or less having the same slope and momentum as the sustainability society coming in. So these two trends, they need to collaborate in order to work this extremely difficult and extremely important problem to really work it out. And for the water industry, we are only one player among many. So I think it's important that we do it and everybody else do it. But we really, because this is our expertise, this is also our moral obligation, and we really have to work very dedicated on these issues.
So thank you, Pernille. Now, seeing as you set up your fellow countrymen with the nice comment about nitrous oxide, Mikkel, do you want to go next?
So I see if I can share just one screen. So this one here. Here we go. So yes, so I'm Mikkel Andersen. I've worked with Scope 1 emissions from wastewater by more than 10 years, and especially with nitrous oxide. And in terms of what to do or how to achieve, carbon or climate neutrality, I think 3 points are really important here. First of all, as Pernille also said, reduce energy consumption at the wastewater treatment plants. This is by far the largest consumer in the community is handling of water, especially for aeration. But we've come a very long way in especially in Europe and Northern Europe in terms of reducing this. And the reduction here is mainly coming from installing energy efficient equipment, but also from doing a smart control. So the digital part that Pernille also said, that we put new sensors and we put advanced controllers into play to minimize the energy consumption and also have the metering of energy use so that we can decrease energy consumption even more. And what has then become clear, especially in Denmark, after running monitoring programs for Scope 1 emissions, both nitrous oxide but also methane are actually pollutants in terms of CO2 equivalents that we need to deal with. These are pure Scope 1 emissions, meaning that they are coming from the water utilities themselves and not by purchasing, for example, electricity, which is Scope 2. And then as the third stepping stone, it's really to think not in producing kilowatt electricity, but rather producing sustainable to make a sustainable energy production. So the carbon or the resources they actually get in, that you turn them into renewable energy forms and not just electricity, because electricity within 20 years will be completely green from green energy and without the water utilities having to do anything at all. But of course, becoming energy neutral is of course also producing your own energy. So for me, and in Denmark, we see that around on a Danish scale, 72% of all the emissions of CO2 equivalents are actually coming from nitrous oxide. So this is where I see the biggest challenge in terms of emissions, but also the biggest and the cheapest opportunities.
Thank you, Mikkel. Now, I noticed some advanced controllers in there, and that naturally passes the ball over to Andy Thornton of HAC.
So I suppose, from my perspective I think advanced control is highly pertinent here, but I don't think it's the only thing. Yeah. And I think if you're asking the question, one thing we need to do to make this possible is collaborate. And I really think, you know, we need to go to a level of collaboration that we haven't gone to before, because we're always faced, especially with the supply chain, of this looming thing of intellectual property. Yeah. And we've got to find a way of how we can work together, even in the face of intellectual property, because that's our business. We develop instrumentation, we develop solutions, and intellectual property is really important for us. But I think to really get on board, we've got to bring in all of the stakeholders, because I don't think the water industry can solve it as an island. So I think the supply chain is absolutely key, because if we go back to what Mikhail was saying, you know, yes, we can use energy efficient equipment, and that's important, and we need to drive the supply chain to do that. But also we need to think as well about the policymakers, maybe opening up opportunities for us to operate our business in a different way, to make sure, you know, that we have the best opportunity to drive any of those solutions. And then also the people who contribute to the pollution. You know, I mean, sometimes we're, as a water industry, we're faced with whatever comes into the treatment plant we need to deal with. And I think we need to be broadening the conversation out to talk to people, especially industry that is a significant contributor to the waste that we treat, about what we can do to help treat that waste at source or make it less impactful on our energy consumption. And then finally, the customers. I think we need to engage more with the customers, and it's also to do with their behavior. It's about maybe changing the behavior of the customers generally to help us with this, you know, this, which is like a mammoth undertaking, I think. Yeah. So I really, for me, I mean, I'm naturally a collaborative person. I want to collaborate, and sometimes it's very difficult to collaborate, you know, especially as a small startup organization who's maybe got some great ideas, which isn't describing me, but there are people out there with great products and great opportunities. And I think we need to give them a voice, and we need to find a way to bring all of the stakeholders together, because without collaboration, I think it's going to be highly difficult.
Absolutely, Andy. So on collaboration, I think we'll move on to Pete Vale, so who I know is an absolute master at collaboration.
So yeah, no, so let me introduce myself. I'm Pete Vale. I'm now the carbon and circular economy architect at Severn Trent Water. So my role really is to try and plot out the route for us to get to net zero by 2030, which as has already been said, is a significant challenge, but of course also opens up loads of opportunity to really drive forward some innovative, clever ideas. And yeah, I suppose as I say, I echo really what's gone on before. All are really sort of valid points. I mean, definitely think it's the case that we need to get better at measuring. So it's difficult to change things and plot out the route unless we truly understand what the current status quo is, what the baseline is, for example, for process emissions. And we're improving on that, but we've still got quite a way to go. Collaboration, yeah, is absolutely key. And I'll if I just I'll try and bring up a slide or two if I can. I think it's just embracing change. You know, it's embracing circularity. It's really committing to this need for transformational change. So it's moving away from what we've done very successfully for a very long time, and it's developing those sort of much more circular, carbon neutral flow sheets. And a lot of that, I agree, is about collaboration. So it's collaborating as an industry. I think it's actually really helpful to have, although it's an ambitious target 2030, I think it's really useful to have a sort of a definitive timeline to work to, because that sort of mission-based innovation, I think it works well. We've got to get better at collaboration as water companies, and we need to look wider. We need to be more international, from a UK perspective, more internationally out facing, but also we need to be pulling in the knowledge from other sectors. And one thing that I might talk about a bit later if I get the opportunity, is to talk about, you know, how we make the change in terms of the sort of technology change. So how do we go from, there are loads and loads of really clever ideas out there, but of course that comes with risk. So how do we reduce the risk, and how, because if we're going to meet the 2030 deadline, we're going to have to be building stuff at big scale very soon. So how can we develop test beds and our approach to sort of validating technologies much more quickly than we have in the past? And then I suppose a final point is, so let's not forget that technology development is just one part of the jigsaw. There's a lot of work that needs to be done, I think, around, again, back to collaboration, but around how we influence and change regulation and how we develop the market for example, for recovered materials. So yeah, I'm not sure that was one thing, Oliver, but
no, that's absolutely fantastic, Pete. And if we don't get round to what you want to cover, then we will get round to what you want to cover. Just drop a subtle hint of this is what I'm going to talk about. Talking about circular economy, there's only one person I talk to about circular economy, and that's Steve Palmer. Steve.
Hi, Oliver. Am I coming through now?
You are, yeah.
Okay. And so just briefly, I'm going to talk about what the big picture is in terms of what we're looking at for wastewater treatment. So today I'm just going to look at wastewater treatment and pick up from what Pete was saying about how we need to deal with this problem where we've got two sets of emissions. We've got emissions related to electricity, over which a fair bit of progress has been made, but we still want to become more efficient on that score. But then the other problem we're left with now is just how much emission we've got coming from processes themselves during treatment, the nitrous oxide and methane being the main part of that. And through treatment and the physical balance that constitutes treatment, which is what we're looking at the moment. When we draw a thermodynamic diagram up for what's happening, we end up with wastes in proportion to how intensive our treatment is. And that has some interesting effects, because when we tie it into the cost paradigm, it shows us where we need to be investing in treatment and where we need to focus down on treatment and its efficiency and what it's doing in terms of the emissions. So one of the issues that we face is that when we look at treatment systems in total, physical economies of scale mean that the very largest treatment works, the ones that actually do the bulk of the work, those are actually the most efficient in terms of pound per PE spent on CapEx and on OpEx. So there's a kind of power law relationship to that. But what it means is, as our works get bigger, we have economies of scale that make them more cost efficient, both in terms of capital and in terms of operation. And in fact, if we look across our entire asset base, less than 20% of the works by number do more than 80% of the treatment work. If we then look at how that work translates into technologies carrying the work out, different technologies have different footprints in terms of their energy demand. So when we look at our scope 2 emissions and power demand, that varies a lot and it follows the same pattern. So work intensity and efficiency of work, the actual work intensity for PE is the lowest at the largest works. So in terms of scope 2 emissions, although we have relatively efficient use of electricity at very large treatment works, we have huge energy budgets at large treatment works because of the amount of treatment that's going on. So our biggest energy budgets sit with our biggest treatment works. But if we then look at what's happening in terms of our scope 1 emissions, which is what we've been talking about today in particular, our scope 1 emissions are a problem on the other side of the equation. So what's coming out of the treatment process are off gases. Those off gases include nitrous oxide and methane, and those fugitive emissions constitute our scope 1 process emissions profile. And that is most intense where our treatment is most intense. So our biggest treatment works are also the source of our largest methane and nitrous oxide emissions. And those emissions are particularly high at STC, sludge treatment centers. So overall, what we're looking at is a picture where we need to align our strategy and our strategies for asset development and asset investment with what we need to do to bring down our process emissions. And that is particularly important in terms of getting the best for value for money as we go forward, because as Pete's indicated, we will need to spend a lot of money and put a lot of equipment in place. And a large amount of that will come down to us maximizing the efficiency of these assets, including those that are already quite efficient. And what that means is we need a lot of sensors, we need a lot of monitoring, we need a deeper understanding of the kind of trends I'm just showing you and how we can actually bring down those emissions at those large treatment works in particular. And part of that, and part of the promise that comes from increased monitoring and increased data analysis and increased understanding of process emissions overall, is if we can increase our monitoring and increase our understanding, a lot of the pattern of how these emissions occur is down to what's happening physically within the works and biologically within the treatment works. So by increasing understanding and having a system with more monitoring in, one target that we can all move towards in future potentially is an autonomous treatment works, where the works runs by itself to a large degree from an AI, and there is less in the way of jumps in performance, and the works itself is strategically managed by its operators, and in effect runs itself day to day. Now that's a long way off, but we've got stuff at the moment developing that could take us there. So I think that's a good point to hand back to the group.
So it reminds me slightly. Andy, myself, Simon Mazier, and Michael Dooley, an evening at WEM a few years ago, sat around a table and went, how do we get multivariate process control, real-time control, and some really nice ASP control into a treatment works and get that really controlled as tightly as it can be. So it was, that never happened, of course, as a lot of conversations don't happen in the water industry. And it was a conversation over a pint of beer, and it had so much potential. At the time, it wasn't cost beneficial. It would have been an incredibly expensive project, but boy, would we have got some great results. And I'm sure, based on what Steve's just said, Mikkel's got some comments, because yeah, nitrous oxide, plant stability work hand in hand. But I do want to jump to Mehdi first and allow Mehdi to talk about Toy Town, because Mehdi introduced Toy Town to me, and it came up with some really nice results. So Mehdi from the University of Exeter, talk to him about serious gaming and in particular Toy Town, or is it a different town now?
No, it's Toy Town. It's going to be Aquatech town during Aquatech event, and then it's going to revert back to Toy Town. Thank you, Steve, because you gave me some ideas. We had a conversation a while ago. It was about exergy, about the value in wastewater, and it actually led to some interesting ideas in there. So let me show you guys. There's nothing like a little demonstration. So let's see. Screen share. First of all, can you see my screen?
Yes, we can.
Yeah.
Excellent. Let me try to minimize this silly window that I seem to have somewhere there. All right. So this game is actually online. It's called a serious game because it's about learning. We have actually a scientific model in the background that simulate what happens to the next 20 years in some imaginary town that we called Toy Town, with around 300,000 inhabitants. And this is what you see when you open your web browser at the given address. Now, everything you see, all the components you see are interactive in the sense that you can change some parameters, but they're also connected to each other. So the goal of that particular game there was to increase circular economy, but circular economy contains lots of things. Scores about water, water reuse, energy use, also about material reuse, also financial parameters and different things. But let me present very briefly what's going on the screen, and then I will try to answer your question with my little toy tool in order to perhaps give you a different perspective. So what you're seeing is an imaginary virtual catchment. The purple thing on the top right is your main reservoir, and it's associated with a measure of stress. So we run a simulation over 20 years, and if I click on it, actually tells you if you've got a stress of 90%, that means that 90% of the year, of all these years, there will be more than 10 days every year where the reservoir is half full or less. So that's how we measure stress as far as the reservoir is concerned. We also measure the water demand met. So it's kind of a similar concept. It's like every year, if the reservoir is completely empty for at least 10 days, then it's a stressed year because for 10 days, you cannot meet your water demand. So the reservoir itself is connected to a drinking water treatment plant. And itself, it provides water to households. We got 3 neighborhoods, so we can change with a percentage, you know, divide the number of houses in the town into neighborhoods of unequal size if we want, and check, for example, what happens if you put certain types of technology in a group of houses, and in another group, bigger group, a different type of technology as far as water is concerned, and then see the overall result. So once the water is used by the household, it becomes wastewater, and it's there treated by the primary wastewater treatment plant, the big rectangle at the bottom. So the game gives you options in which you can change connection. You can instead use decentralized wastewater treatment. Once the water is treated, it goes back to the river, and that's a very rough overview. So we are looking, when we look at circular economy, we look at many things: environmental pollution. Here for pollution, what we measure when I click on this is actually the number of events which are uncontrolled discharge, and therefore because of the concentration of nutrient in the river, we measure the cumulative depth of oxygen, if you want, in the water. And from there, we have this little pollution index that gives us an indication of pollution. Another bit is we also look at energy, and this is where it's getting really interesting and relevant to that question: energy and material reuse, 2 absolutely crucial points. So let me click on perhaps this household thing, and you could see, actually, I'm going to click on another one, which is even more detailed. This is the share of energy use between the household and the water treatment. And you'll notice that as far as the energy used for water, so in some energy, you could see that 98% of the energy used comes from the household, and 2% is about the wastewater treatment plant. So what it tells us first is that if you want to make economies of energy and minimize emission, well, perhaps you're better off trying to find strategies to minimize your energy consumption at the level of the household, because you'll save on 98%. Let me give you a very striking example. I'm gonna select for all the houses in the neighborhood A, which is 100% of the house in town. I'm gonna just change a shower head. So if I change the conventional shower for something like a fog shower, which mix air and water so that you spend less water, you actually save not only water, but you save a significant amount of energy. If you look at the bottom, energy consumption is 12.5 gigawatt hour per year in average. for your wastewater treatment plant, if I just, in every house, if I was to just put a fog shower head, then it would become 10. We've saved, just by doing that small adjustment, we've saved a significant amount of energy. And in fact, we have saved 2 gigawatt-hour at the main water treatment plant level. But if I revert and I look at here, what is the household consumption? Household consumption was 618 gigawatt-hour, and by changing just a shower head, which is the most unassuming element you can find, it becomes 434 gigawatt. We saved 200 gigawatt-hour. So first, reply to your question, part one, I would say, is if you want to save energy, look at household use of water and energy, and this is where most of it can be saved. Well, the second answer is actually a little bit different. There is another aspect to it, which is actually in the wastewater itself. Now, something very interesting happened. The wastewater contains, if I click on material reuse, it contains a lot of things. It also contains metals. In particular, when you have human activity, it concentrates all sorts of metals which are mined and then extracted and refined. And these metals themselves take a lot of energy, exergy more specifically, the amount of energy needed for the metal to be mined and refined from the earth core. So what is amazing is I've made a list with the literature of all the different types. I mean, not all, but 1/3 of the metals you could find in the wastewater. And I've put a little here, a little indication which you can actually change the amount you save. And in blue comes what happens if you manage to save 85% of all these metals. For a town of 300,000 inhabitants, basically, if you manage to recover things like aluminum, cadmium, and all these metals, it doesn't look that impressive, okay? It's like the equivalent in energy of energy savings of having 7 wind turbines working all time during 1 year for each year. But it's also the equivalent in carbon sink of planting, roughly speaking, 5% of the surface area of the Netherlands every year. In the fact that you are saving this energy, and this is in carbon sink equivalent, like covering this kind of surface area in forest. Now, what's really, really interesting is only about domestic wastewater. What becomes really, really interesting is if you take into account industrial wastewater, the concentration of metals are actually from 10 times bigger to 10,000 times bigger, especially if you look at industrial areas in China and other areas like that. So what happens is, in fact, if you were to recycle 85% of the metals you find in wastewater, it would be, for a town of 300,000 inhabitants, if you count industry, that would be the equivalent of planting every year 50% of the surface area of the Netherlands in forest, in carbon sink. Now, that's quite interesting. The other interesting bit is the technology doesn't really exist necessarily to recycle all these rare metals from the wastewater. But what's also interesting is only 5 to 6 of these metals, if you only recycle 5 to 6 of this metal, that constitute around 80% of all the exergy you can save. So if you really target things like aluminum, things like gallium, things like you would have to move around some of the thing here to see exactly what happens. Like, for example, if I move aluminum, you can see what you manage to save. It's the equivalent, just by recycling the aluminum, of having 1% of planting 1% of the surface area of the Netherlands in forest every year. And if you add just a few more things, you'll discover like 5 or 6 metals. If you concentrate on them, you can really make a huge difference, energy-wise, exergy-wise, should I say, but also in emission terms. So I think that's my answer to your question.
Thank you, Mehdi. And that's precisely what, two things I wanted to demonstrate there, getting Mehdi to do what he did. Yes, there's a lot we can do at the wastewater treatment works. Of course there is. There's a lot we have to do with the customers. And the customers are absolutely, Peniel, I'll get you to talk about water stewardship because I know it's an incredibly important part of this, but also the power of a serious game. It seems you start talking about serious games. Well, why would we use serious games? But in 5 minutes there, we've just seen quite a lot of the different ties. Yes, we can concentrate on the treatment works. Yes, we can concentrate on producing more energy. Absolutely. Some of that gap, and I know a lot of the companies have got a gap, customer becomes an absolutely essential stakeholder there.
I think there's a very important point as well, Oliver. Sorry to butt in, but I think it's really worth picking up on what Mehdi's done there, because it's so important. And what he's doing by using exergy in the analysis is he's showing how energy and carbon are related across a whole area of activity, from cradle to grave to a degree. Part of the issue here is that current economics simply doesn't include that. There's the doctrine of externalities that's used in conventional economics ignores how some of these costs accumulate between one area of the economy to the other. So at the moment, our policy making and our economic policy making is blind to the type of thing that Mehdi's just showed us, which is that by intercepting certain metals, and there'll be things in there like rare earths that there's talk about opening new mines for in the future, open cast at huge environmental cost. A lot of that material could be covered through wastewater treatment, through municipal sewage treatment. The reason why we don't see the cost benefits at the moment is their costs aren't comprehensive enough. So there's a lot that needs to change going forward, and a lot of it's to do with information. So again, with regards to the gaming, the more information we can provide to point out where we're not understanding things at the moment, the more powerful an argument we've got to get us to start doing the right things.
But I think it's also having that information in a digestible format. And yeah, understanding those links, but understanding it in a way that we can communicate to the policymakers, can communicate to the decision makers, can communicate to whoever we need to communicate to. If I go, Peniel.
Yeah, I think it's extremely interesting, this serious game by Mehdi. And what I really appreciate, which is sort of an aha moment for me also, is that we are very occupied in Denmark, in my utility. Like, we want to be, our utility, it has to be clean. So we have to sort of have zero carbon within our own scope. So it would never have occurred to us to look into rare metal, because it simply doesn't make a bleep in our system. And looking at these fog showers that I never heard about also, I think really to expand the scope, it is even for us, it's very difficult just to find out our own backyard, but to look across it. I think that's very interesting. And I think it could be very helpful for many utilities to play this game, to sort of play around with what can we do. And I'm very impressed.
Yeah, to be honest, I've been trying to get Mehdi to develop a serious game based upon a water company, so people can understand the investment decisions the water company has to make and inform the customers.
Yeah.
But what gets me, and what this brings me back to is the production factory. We saw the Dutch, and correct me if I'm wrong, but it was about 2009, produced the STOA report of the wastewater treatment plant in 2030, long before we even talked about net zero, long before. And it's something I read at the time when it came out and took to heart, because of course I saw instrumentation as a vital part of the production factory approach. Now, it took the Dutch said 2030, so they had a 20, 21, 22 year, 23 year timeline. I would possibly argue, and somebody from Holland would probably tell me I'm wrong, I would say the Dutch have already achieved it. Now, the Dutch are very instrumentation heavy in most of the processes that they produce. The Nerida process, which I know is going in a lot in the UK, is quite instrumentation heavy. The Sharon process, which came and went from Holland, very instrumentation heavy. But it's very much that production factory approach, which to an extent, I suppose we've taken on board in the UK, but not really. And I still think there are some barriers there to the production factory approach. There are certain elements within the wastewater treatment places, especially the sludge treatment centres, that we can't measure. And yes, the production factory, we talked about stability. As far as I'm wrong, do correct me, Mikkel, stability is absolutely essential in that limiting that nitrous oxide production. So how do we get to that sort of carbon neutral production factory approach? Do we? How do we make the best bang for the buck at treatment works? Obviously, yes, there's the working with customers as well, water efficiency, but also energy efficiency. Also, how can we help? So, but is it fair that we're not, in the UK, we're not really a production factory at the treatment works? I would say the only exception to that, I think, is the excellent work that Severn Trent did at Spurnell, which I'm a great admirer of. Why do we not do more of it?
Yeah, thanks, Oliver. I happen to be at Spurnell actually today, so I am looking out the window at our anaerobic MBR, which is 30 or 40 meters away from me. So I think we are making progress. Instrumentation is a really interesting one, isn't it? Because it's definitely part of the picture, part of the solution, but it's only a part of it. And we've long had a strategy in Severn Trent that may or may not prove to be a sound strategy, but I think it makes perfect sense to think of a large urban sewage treatment works as a biorefinery, resource recovery factory, call it what you will. And also recognizing that, the treatment works itself is clearly a really important element of the system, but the system extends up into the network, and having good instrumentation and information from the network really helps you have an efficient, low carbon, low energy treatment process. If you're going to be doing, sophisticated advanced controls, machine learning, AI, even moving towards the sort of digital twin concept, then clearly instrumentation's really, really important. I don't know yet whether we can use sort of lower cost soft sensing approaches, or whether we really will need, on an activated sludge plant, have, maybe we need to measure not DO, ammonia, nitrous oxide, nitrate, nitrite, pH, conductivity. You may need all those things, or you might be able to use sort of soft sensing, mechanistic models and other approaches. But I think it's absolutely right that the focus is on those big works, because as Steve was saying, that's where the bulk of the emissions come from. So if you're plotting a route to net zero, definitely focus on the big works. But don't forget that Severn Trent, for example, have 1,000 works. 700 or so of those are very small. And I don't think instrumentation is the approach there, because you'd need people going out to site regularly and calibrating and maintaining. The small works probably needs that needs a different sort of way of operating, doesn't it? So there may be more nature-based solutions that have a sort of a lower carbon intensity, that don't produce a lot of sludge, don't require lots of operator visits and the carbon associated with that. So I'm agreeing with you, but I'm also, let's not forget the different type of assets we have, and that it's not sort of one size fits all.
Absolutely, Pete. And I do personally, I said this a few years ago at the Urban Drainage UDG Urban Drainage Group conference. We've got to be talking much more about the wastewater system. Yes, it's the network. I think I wrote a paper, an article a few years ago now, that said, yeah, can we control in the network in dry weather, use hyperlocal forecasting in dry weather? Can we use the network as a storage place? The UK is a bit odd, should we say, that we have all our stormwater on the treatment works. A lot of countries aren't like that. Can we use the wastewater network as a storage point? So to balance flows coming into the works. So get that nice stable, even in the flow pattern, get that stability, and that's going to help that consistency. That's going to help the nitrous oxide emissions, getting that beautiful stability, and then use hyperlocal forecasting, as we're seeing it more and more use now, to when we need to react to wet weather, ramp up. And actually, in some ways, that gives us a solution, well, not a solution, a help on the pollution issue that we've got, a help on the net zero issue that we've got, and everything else. The wastewater treatment works is, yes, it's a part of the solution. The wastewater system is a part of the solution. And yes, we've got a multifaceted approach, but how do we get the most from that? Yes, on the big works, on our MinWorths of this world, go crazy. Multivariate process control, real-time control, nitrous oxide detection, absolutely outputting as much as we can energy-wise. And I remember there was a works that I had dealings with. It couldn't actually use all the biogas it produced. So it was flaring off most of the time because the CHP engines were limited because of the actual energy credits they had, the energy limit they were allowed to produce. Now that was before we went down to the biomethane, et cetera, et cetera, et cetera. But yes, we've heard now energy production, energy efficiency, absolutely vital. The exergy issue, great. That's an innovation project on its own. How do we recover? What do we recover? I can hear the innovation fund coming right here, right now, to be honest. Yeah.
The question for me on that, Oliver, I find that gaming very interesting. Is for me, I mean, in a previous life, I used to work in mineral extraction, and I completely understand, about 5% of all the world's energy demand goes on crushing mineral. Yeah, so we're mining mineral in terms of we mine mineral in terms of parts per billion. Yeah, and yet they do that in an economical fashion. So they still get a return on their investment for mining this mineral in parts per billion and crushing it and crushing it and crushing it, recovering it, treating the effluent from all the water that they use, and they make that economically viable. So I would sort of support the fact that we should be looking into recovering some of these elements from our wastewater because they're already refined. They've only got to be separated. Yeah, I mean, for me, you've already got refined metals in your wastewater sludges. It's only a separation issue. And if people can, if organizations are willing to invest large amounts of money in crushing rock until it's of, a usable and quantifiable amount of metal, then surely there must be a way of extracting it from our waste streams. Not for every metal, but I'm sure there's enough valuable metals that there must be a way that we can invest in that. And then if we can offset through that model base the carbon that would be associated with re-energizing those minerals from the Earth's core, then there's got to be a benefit for us all. Yeah.
So I think there's an innovation project right there, to be honest. So
I saw Steve off anyway. So
yeah, I agree with that, Andy. I think that's right. I'd also like to back up what Pete just said, and his last conversation with us, Oliver, because it's very, very important. We have gone down the wrong road in the past. if we start looking at the physics now and we start taking the physics into account and do the right systems analysis, we should understand the difference between the large works and small works. And what small works are the opportunity for in future is for us to redress a problem and going down the wrong route in the past. Because what we've done in the past is pretty much take the same kind of technology hammer and hit the small works with it. And we don't need intensity. When you look at exergy, it's about work and how much work is done and how resources flow through a system. And when you're looking at small works, we should take advantage of the fact that most small works are in rural areas and we can allow them a larger footprint. And what we need from our small works in future is we need them to have low intensity applications. We need to be looking at low intensity natural solutions. We need to balance out the exergy flow through that works by making it a low intensity facility and increasing the variety of services it offers. So in future, small works need to have a wider utility. So if we pursue natural solutions, we can look at solutions that include, say, flood storage and flood management. The same kind of area can be utilized to increase biodiversity. We're not just looking at utilizing areas to increase biodiversity in its own right. Part of that biodiversity can be encouraging growth of willow and other species that lock up carbon. We can encourage the return of some areas of peatland and wetland, which are also carbon sinks, negative carbon areas. So if we take the right approach to natural solutions, we should be able to draw a line somewhere along the 2000 PE or something like that. We can start looking at smaller works and simply say what we should really be doing from the next AMP or so onwards is saying all small work should tend towards natural solutions. And those natural solutions should be broad-based on a wide amenity basis, underpinned by physical analysis. But basically that physical analysis will point you towards generic solutions that go along the lines of having naturally based solutions that have a wide utility and can do a number of things at the same time. And those things include issues that we've got at the moment, like carbon, like having to deal with flooding that is more of a risk as a result of climate change. It's easy to map a natural solution on a wider footprint to a series of outcomes if we identify the outcomes as being something that we want from that category of assets going forward.
So we're talking more sort of lagoon facilities.
There's a whole range. I mean, it's not just lagoons. So it could be lagoon type systems, but it could be a mixture of systems. So it's also possible to increase intensity where we need to. So for example, one of the things that you could do is have a natural solution with a side stream on it or a small side reactor that's quite intensive, where you also have some solar PV or a wind turbine to provide electricity to that. So there's nothing to stop you producing a small natural solution that it will have a larger footprint, but it could also be adapted in terms of intensity by looking at where the intensity is required for whatever aspect that is. Won't normally be the BOD or the COD out in the countryside. It's more likely to be nutrient, phosphorus or ammonia. But again, it's something that's entirely possible. And we have other technologies at the moment where we can add to existing technologies. Microvi, as an example, might be a way of bringing in biotreatment to systems that otherwise don't have intensive levels of biotreatment. So there are ways of actually having a small degree of intensity where we need to have it on a small scale, but not simply putting out a technology solution, an intensive technology solution, which is better suited to large works. I think we need to move away from that model. And I think it's quite clear where we need to go, because if we map out what we want from those small works in future, that will then describe a space and an idea, a concept for what it is that we build.
And of course, those smaller works with those low intensity solutions having less of an impact. So I mean, we talked about, what was it, the type 1 emissions majority being from the larger work. So when I look at, say, Yorkshire, I think 70% of all their wastewater is through 2021 sites. That's obviously a big place that we can have impact. that we can limit our carbon emissions. Is it nitrous oxide control, Mikael? I know you're going to say, of course it is. It's nitrous, it's methane, but what are we doing wrong?
Well, you're not doing anything wrong. Let me share a slide, because I actually agree with a lot of what has been said. Because here in Denmark, we've been monitoring nitrous oxide and also methane, I should say, for the duration of the last 2-3 years. And what is quite clear is that it's actually the bigger wastewater treatment plants that have the highest emission. But that being said, it's also the emission plants that have all the tools and know-how and sensors and logics to actually treat the problem. One comment on the high intensity reactors being small or not. We actually see that all side stream reactors that we have measured on have a much higher impact in terms of climate impact than conventional ASPs have. So when we talk intensity in terms of nutrients per volume per time unit, we have to really be careful in terms of what we implement. But what is also clear is that if you look at this is the Danish context, around 30 of the biggest wastewater treatment plants are treating more than half of all the wastewater in Denmark. And then I think the rest of the 700, a lot of these will do quite well with wetland or constructed wetland type of wastewater treatment plants, where infrastructure in terms of sensors and so are not at all needed, because these are more passive systems that go about their business and are quite happy to be overflowed with stormwater if that should happen as well. One element that is really important here, and let me just stop, and that is the regulation, because there's a driver here as well. So gamification is one way of putting focus on an issue, and you mentioned before that Denmark is ahead in many cases, and one of the reasons why we actually ahead is that we have a really good collaboration between the environmental department in environmental ministry and then the utilities. So actually the N2O regulation in Denmark, that came about on the background of monitoring for a couple of years to give the tools and the first know-how for the EPA to start to regulate the for example here the nitrous oxide, and there's similar on methane where they're looking into this. But in last year in 2020 they passed a new climate plan where the utilities will start to monitor and have regulations around the emissions of nitrous oxide, which is by far the most the biggest part of the scope 1 emissions. But there is a limit to who should do this, and here it's actually not 2,000 PE but 30,000 PEs, because below that then the waterworks are too small, and often they lack all the instrumentation needed. But in essence, by 2025, they will start to regulate and diminish the amount of emissions, scope 1 emissions. So the thing that actually is so important, and this is the link to the gamification, that is actually the awareness. So how do we actually educate both utilities, but also end users, which are metering their waters by use and then paying a fee on the wastewater that they deliver. And one thing that has been done in Denmark and driven by the EPA in Denmark is that we have this what we call the Paris model, which is a really simple framework to implement and document and also make a sort of an inventory of emissions, use of electricity, and how much green energy is produced, so that we can start to actually see what makes sense in terms of mitigating nitrous oxide, what makes sense in terms of producing biomethane and convert it up to full natural gas. And actually now the water utilities in Denmark are starting on a simple scheme to benchmark one another against each other, and they've done that for a decade or more in terms of kilowatt hours produced and used. But now it's also a climate bookkeeping that will be placed. And in the end, the driver for all utilities, and I think that is the same in the UK, we need the regulation in order to allow utilities to charge the end user for the implementations in terms of more expensive technology and so forth. So it starts in Denmark by inducing incentives to do something about the problem, and then afterwards, rethink the regulation so that you can actually think the solution in as a sector thing. And I think Pernille can tell you a lot more about all the problems that there are when we have strict regulations around water and heat and similar. But actually, a carbon tax is one of the simplest tools that we can implement if you want to become net zero, because then you get the economic driver both for the end user, for the utilities and for the public in general. So this is also a thing that I think should be kept high in terms of the wish if you want a driver that is very efficient.
Interesting stuff. I mean, in the UK, I know we've been aware of nitrous and certainly aware of emissions. Do we monitor it? I don't think so. Should we monitor it? Perhaps. But is that because there's no driver to monitor it, so we don't?
So we've started monitoring. We've got one site that we've been monitoring emissions from for 7 months, and getting some really interesting data, has to be said. Just reinforcing this. Nitrous oxide emissions vary seasonally, diurnally, spatially, and the emission factor is admittedly just based on one site at the moment, but it is substantially higher than we would currently report through the carbon accounting workbook. And I think there's a real logic for why the carbon accounting workbook was developed. It means it's consistent, but I think we as an industry recognise that it's becoming outdated, and we definitely need a much wider monitoring programme, which doesn't necessarily mean that all works in future will have to have nitrous oxide monitoring on it, but we certainly need to rapidly expand the monitoring programme to cover different types of works, and I'm talking UK wide here, not Southern Trent, and we're all working together on this and trying to work out the best way of doing it. But it needs different unit processes, different types of works, and going back to the collaboration theme, it's essential that all that information is shared so we can come up with the right strategy and the right way of accounting. Because the approach we take at the moment, where our nitrous oxide, we report nitrous oxide emissions just driven off population equivalent and the ammonia load that comes into the works, and take no account of the unit process or how you operate that plant. So I'm convinced that will change and needs to change. But as I say, we need to ramp up our monitoring activity, certainly.
To be honest, to me it would sound, from what Mikkel's done, I'd say all size 6 works should have it. I think that'd be fair to say, and maybe going down in size 5. In some case, that's a no-brainer. 5s and 6s, and it's not that many. 200 works nationwide? Probably about that. Mikkel, what's the price for an nitrous oxide sensor?
Well, in pounds, I don't know, Peter, but I think it's an investment very similar to the analyte sensors that you'll see around. So monitoring for sort of a 2 sensor setup is around 8,000, 9,000 euros, depending on the accessories and so. So it's fairly similar to I'd say advanced analyte controllers. But if we look at how to use it, and when it comes to mitigating nitrous oxide afterwards, and you account the cost of a ton CO2 equivalent mitigated, then the cost is actually very, very low compared to a lot of the other technologies that are out there. So that's another way to try to price set a piece of equipment that can actually be used for mitigation.
But okay, I'll take a ballpark figure there. 20 grand installed.
Yeah,
not far off. 20 grand installed.
No, I mean the other thing to point out, perhaps, Oliver. So you then get a reading of your aqueous phase or your dissolved nitrous oxide. You do need to do some work then to calculate the gaseous emission, but that's a sort of a calculation and airflow measurement but yeah,
20 grand installed. What we're talking about, 2 million for 100 quid. So we're talking 6 million quid nationwide.
Well, I come back to this conversation quite a lot, and obviously I'm going to have my own view because I work for an instrumentation supply company. But focusing just on the capex alone, there's a few. It's course, just I can. If you're putting an instrument of any sort, not just what we provide, into the right application, you will get a return on investment. Yeah, you will do. It's not always easy to prove, because one of the biggest values of putting instrumentation in is freeing up operator time for other things. Yeah, that's really highly valuable, especially when you're offsetting lab processes, intensive laboratory processes. But also, I think, looking at, say, nitrous oxide or anything in isolation, I'd like to go back to that game and the comment I made at the start about collaboration. Putting a box around a process is really counterproductive. Yeah, I really think that it is. And we've done it ourselves as a water industry for years. We just put a line between sludge and wastewater, which never made sense to me. They're the same process. Yeah. So I think we just have to be careful about looking at things in isolation. We're really focusing on N2O because one of our biggest solutions in the UK especially is nitrification RTC, and we are now looking at redeveloping the software to ensure that delivers minimum N2O whilst meeting compliance and minimizing energy. So there's a different element now, and there's a different balance there that we've got to do, but we've got to work on that. However, just the point about customer behavior and the impact that can make, and recovering, it still probably isn't economically viable to recover nutrients from our sludge streams yet, but we're getting closer than we used to be. Yeah, and at least we have the technologies there ready to go, and we can push the button, and maybe we can make them more efficient, because that will also have an inherent impact on the producing fertilizer, from mining these ores, really, again, has a big carbon footprint. So we should be able to bring all of those things into the calculation. And I'm probably laboring the point now, so I'll shut up. But I really think it is dangerous to just put a box around a process and say, right, we've got to do all this from this box. We've got to go from where we are now to somewhere else without considering the outside impacts.
No, I agree, Andy. Yeah, and you make a good point about looking much broader and wider, and looking at the system. I think ammonia is the absolute poster boy sort of example of this, if that's a good phrase. I don't think it is really, but yeah, as you rightly say, ammonia, as we've learned from the news of late, it's massively carbon intensive.
Yeah,
isn't it? The couple of fertilizer in the plants in the UK have shut down because natural gas is so expensive at the moment. And yet we've got loads of ammonia in our waste recovery. Not only are we being able to produce, a much more sustainable low carbon fertilizer, and then offsetting that carbon intensive process, Haber-Bosch process, but we're also removing the ammonia that would be converted through to nitrate, nitrogen, and produce the nitrous oxide emission. Yeah. It makes sense on so many levels.
Yeah, another point as well I'd like to raise there, Peter, which is the way we treat our sludges. I mean, we've come up with some great ideas about centralizing our sludge system, and we've got these immaculate thermal hydrolysis plants, and we design them to the nth degree, and we make sure everything's perfect. But actually, we don't design the system. We then send substandard sludges from satellite sites where we've made little or no investment that defeats the object of building this central facility. And that's what I mean about putting a box around something. The box should always be around the system. Yeah.
I'd like to back up what you're both saying there, because the whole box thing, I've started doing some preliminary exergy analysis across asset base on a sort of generic basis. So it's sort of based on the thermodynamic modeling. But the bottom line is there is a divergence. The holistic approach is absolutely essential, because if you take the holistic approach, you can start to see some of the things that we were seeing earlier when Mehdi showed us what happened when we started modeling the system. And when you start modeling the system on the right basis, on an exergy basis in this case, one of the things that becomes apparent is if you're looking at small works, let's just say less than 2000 PE, looking at low intensity solutions, you're going to take your design approach and change it to one of exergy suppression in future. So what you're going to do is look for designs and outcomes that have a widespread utility, that give you a lot of natural capital, but basically have a low exergy flux through them. Now that just gives you a way of putting everything together that fits a big picture. The same big picture gives you a completely different outcome if you look at category 6 works, because the very big sewage works, there you'd need to design on the basis of exergy management and exergy recovery. The thing there is, on the very big works, on small works, it's not too expensive to actually create headroom and run a passive works where you don't need much intervention and much control. On the very large works, which is, again, just to remind us all, where 80% or 90% of the treatment work is done, where 80% of the treatment work is being done is on facilities where headroom is very expensive. So that's where we need to have more monitoring and management, because we need to manage headroom. It's too expensive to build headroom in. And if we take a view of exergy recovery and management, what it means is we're looking then at not just managing the headroom by managing the exergy implications in terms of the headroom and all of the resources. We're also looking at the resources that pass through the facility, because those facilities give us the best exergy returns in terms of strategic exergy return. And that's something that the gaming showed us earlier when Mehdi was talking about, for example, certain metals being targeted because they're high value.
To add to that, there is a very interesting picture I want to show you guys. I think I'm not a specialist in exergy or anything, so you're gonna have to excuse okay, can you see that curve?
Yeah.
All right, these are signaling in time the maximum point of exploitation for different types of metal. Here is a list, it's more readable. Now, what's interesting is sensors are going to become quite interestingly useful if you can determine the quantities, or at least the concentration of this different type of metal, particularly those in red, because they're already running out and it's going to become exponentially more expensive past the date where you've got this peak. It's going to become exponentially more expensive to mine them. So, for example, something as unassuming as nickel, it's the peak happens in 2033 for mining nickel, and at the moment it's around $20 per ton. But if you project yourself, let's say a couple of generations, 40 years later, that ton of nickel that you did not try to recycle in your wastewater system will be worth not $20, but $600 or more. As it follows an exponential curve, I mean, we can let our imagination go a bit crazy, but it's not just it's not just nickel. Things like lithium, it's actually gonna, the top point for mining nickel is in 2037. After that, it's gonna become exponentially expensive, more expensive to mine it. So finding sensors that can identify these key metals, which are, you know, an endangered species, if I may say so, is gonna become exponentially more profitable as time goes by.
Pernille, you've had your hand up for quite a while.
Yeah.
Do you want to chip in?
Yeah, I'll take it down now. So, if we think of this in terms of stewardship, and you may call it water stewardship, and I saw Rökström, he just called it, we are all now, he called it planet stewards. So he had this idea of planet stewardship. We really have a very, very difficult task within the next 10, 20 years to succeed with this transition. And in order to do that, I think this team is absolutely fantastic, and I would love to invite you all to come to Hillerød and just try to sort of make that maybe based on maybe this gamification thing. Can we perhaps put in the Hillerød utilities number to really have this system view that Stephen talks about, and also understanding the exergy and have the sensor so that we actually know. Right now we are flying blindfolded in a very, very difficult terrain, and we don't even know what really counts. Is it the metals or what is it? And to have this focus also on nitrous oxides, to have all of this integrated into one solution. And it reminds me, I have been an opponent to a couple of PhDs in Denmark, and what they're working on is to integrating the water stream with the energy system. You could aerate when the energy is cheap, or you could do it while the environmental load is low, or you could aerate while you sort of reduce ammonia a lot. And suddenly when you become very clever at this, and these guys, they're very clever at it, you really have to choose. Is it money? Is it CO2 load? Is it nitrous oxide? Is it nitrogen? Is it CO2 from the energy system? What is actually important? And I think as long as we adjust all of this, and this could be nice improvement, I think there are really a lot of nice improvements. But before we have this integrated understanding, we can't really do the right thing, because we might so easily invest our focus and our energy on the wrong place. So we really have to be very in digitalization. I think we were at the same session once. Oliver, I can't remember who said it, but I really say it a lot and say, from a digitalization point of view, Frodo has just left the Shire. That's how far we've come. So there's really a long way to go to have this holistic, systematic understanding how to integrate with our surrounding, with the energy system, prioritizing between the different things to sort of steer the whole Earth into a sustainable range. And this is extremely interesting and extremely difficult. And we really, we cannot keep on discussing, is this too expensive for this sensor or not? Come on, guys. We really have a real problem here. We need to solve it. And we need, as I said in the beginning, we need to build it up like small steps all the time, improvement. And if we do not get started, we won't manage it, simply. So we have to get serious. Apropos also your serious game, we have to get serious about this challenge we have before us. We have to be serious about stewardship. We have to really understand the system and how do we and the listeners here who are clever in this, how do we spend our focus? Where are we spending our attention? It is extremely important now and in the next 10 years. And 10 years is nothing. Just blink your eyes, and 10 years just gone by. So we really have to think hard now.
I think another point is there, you just reminded me of, Pernille, is we have to find a way to speed things up by having more trust in others' investigations, trials, you know, and we need to be willing to import already proven technology from other customers. I think that's still a stumbling block that we have here. Sometimes, you know, quite often, you know, as a company, we quite often used to do things in Germany first because we originally were a Germany central organization. And I mean, that's changed now. We do a lot of our stuff in the US, but quite often we get comments, we don't want something importing from Europe without, you know, first testing the hell out of it. And I think why we need to manage the risk, and we do need to do tests and trials, you know, sometimes we do that. We go to the point of overkill with that, where the supply chain almost loses interest because it's not a bottomless pit. Yeah.
And it's not serious. It's not serious on the part of the utilities. The utilities have these problems, so go on and solve it. And it's very easy staying in this safe area where we play it safe because we are getting all kinds of from all kinds of sides. But we really also have a problem that we need to solve within the next 9 years now, and we have to get serious.
And I think that's the point, to be honest. 9 years and counting. When I started this by saying I do a lot of professional interviews, and I asked the question, one of the questions I asked, because I want to see the candidate's honesty: can the water industry achieve net zero by 2030? And the vast majority say no, we can't. And even say 2050 is tight. So yeah, there is an action point. We've got to move in the right way. And I think actually to be fair, the water companies are moving in the right way. They do know there are things that they are doing now. They do know that there are things to investigate. Pete, you doing the anaerobic MBR at Spernal is amazing. I'll quite happily say it. We are doing things. There is a plan, but there's also that gap. And I think most water companies have said there's a gap that we don't know where that's going to come from. What more can we do? Well, there's quite a lot to go at. Andrew Chappell on the chat has said, so what is the next step? I think we're already taking some steps, but I think the water companies have, in the UK at least, have produced plans. They've all published those plans. They've all said, this is where we're going. Brilliant. They've all said, but there's a gap. How do we address that gap? To be honest, I think we've had a fascinating conversation here today, and we've brought things out of each other. It's why I brought this together. I knew this group of people would come out with some moments, and I think we have in the past hour and a half, believe it or not. So to wrap this up, what are your takeaways from today? Neil?
I think this has been a very nice and interesting conversation, and I'm always very happy when things sort of get to me on an emotional level. And I think what I'm going to ask the organization every day is: are we serious? Are we really serious here?
Pete?
Yeah, I agree. It's been a really thought-provoking discussion for me. I think it's clear to me there are so many sort of angles and different ways of looking at this. Peniel's absolutely right. Centrally, are we serious about delivering this change? And that clearly, we all need to step up to the mark and make sure that that's the case. But then, there's sort of the different sort of ways of, from sensing and data, serious gaming, changing the sort of technical process, the unit process, looking at incentives, carbon taxes have been talked about. Looking at it very fundamentally is brilliant, isn't it? So I've heard Steve a couple of times now talk about exergy and thermodynamics, and each time I get a little bit more, and I'm probably still not quite understanding it in its detail. But yeah, so take-home message for me is, yeah, just make sure we look broadly and think about the whole system and not just focus in on narrow areas.
Andy.
Yeah, so I'm glad that Peter understands Steve. Maybe I can understand Peter and then learn to understand Steve. I think so. My take. You know me. The first thing I want us to do is to look broad and collaborate. But I also some of this has been thought provoking for me from perspective of the game, and maybe I also have to look at my own personal impact. And maybe if everybody did that a bit more than we currently do, yeah, you always get the feeling that you can't really make a difference on your own, yeah. And maybe it's time that we got the message out there to people, to the customers and to other polluters, that actually we need to work as a team to do it. And maybe I should also do my bit. Maybe we should have a regulation on what type of shower you can have. Yeah, maybe that's.
I'm sure Mehdi will show us it's not only just the showers. So Mehdi.
Yeah. Well, first, I'm super pleased with the feedback I have from you guys. So I invite you whenever you want to use a series game, even if you want actually to modify a bit the model, adapt it a bit to show different things, give me a shout. I'll be happy to help. But the thing for me that I find quite interesting is there is 3 types of stakeholder. There's the citizens, whatever they do, they use less water, they shower less or more, whatever. Then there is the businesses, and then there is the policy makers. What I'm interested next is what happens when you can simulate the different things that you can do with these 3 different types of people. Like, for example, right, you were talking of taxes. If you're a policy maker, if you create a tax, let's say you cannot claim to be reimbursed on your expenses of electricity and water unless you have a special, let's say, environmentally friendly way of doing your water, or counter, or something that spends less water, for example. So if you put such a tax, it will impact the system of the stakeholders, of the citizens and of the businesses, right? If you're a business, let's say you create a new type of ISO norm, and if you're certified higher level, spending less water or something, then you got preferential access to a market of customers you didn't have before. That's another way you can interact at the same level. So it's like, I'm not sure if it's a serious game or decision support system. And if you're a citizen, of course, you can do your bit. But modelizing all the 3 together would be something interesting as well. So, well, anyway, another idea, always lots of ideas. But guys, I'll be happy to work with you whenever.
See, this is quite interesting because the social science point of view is really interesting. And yeah, can we bring social science into serious gaming? That's a bit of a development. So, Mikkel.
Yeah, I think the take home for me here is really that we have to work on decoupling return of investment and actually climate improvements, because that's the only way that we can move forward, and maybe also answering whether we are serious or not, because purifying and cleaning up is not cheap. It costs money. So talking of return of investment and then still achieving climate and energy neutrality, that's not easy. So I think maybe a driver or regulation and so are needed, because it's the only way that you get the incentives and instruments that we know work, that will actually move things forward. And actually regulations will put in place the technologies that we already have today, rather than pushing innovation in front of us as the solution to a lot. Still a lot to be done, and maybe urban mining that will be something of the future, and cost will actually drive that technology, I'm sure, in the future.
And finally, Steve.
Oh,
There you go. Yeah.
all right. Okay. Yeah. Yeah. I think going forward, the big issue we've got is we have very little time. We're standing at the bus stop. The bus is actually 10 yards away and it's accelerating, and we need to run to catch up. And if we don't start running soon, we won't catch it at all. So that's the big problem. And I agree with Mikkel. Part of the issue is we need to decouple what's happening in terms of costs, because costs are moving. How we do costs is moving and changing, but we can't wait for that to happen because economists are moving all the time and they're counting and costing more things all the time. We need to be making allowances now. So Mikkel's absolutely right. We need to be changing regulation now. For the UK, the government needs to do more than just set targets. It needs to not just pass the problem on to industry. It needs to push, it needs to cajole, and it needs to get involved, because the bus is going and we are going to miss it if we don't start moving.
I think at that, it's a perfect opportunity to bring things to a close. Say thank you to everybody on this panel, on this roundtable. When I brought you all together, I knew it was going to be a fascinating conversation, and I certainly wasn't disappointed. I hope everyone in the audience has enjoyed themselves, and I hope you've enjoyed the WIPAc forums and roundtables over the past couple of days. I must admit, it's been a privilege to host them all. We will, of course, see you all, hopefully, at next year's WWEM in 2022, which will, everything going well, hopefully all be actually physical this time. Hopefully see you all next year at WWEM, and do feed back to me what you'd like to see at WWEM, because I'm always working with the organisers to bring new and innovative discussions. So thank you for everyone. Thank you to all of the speakers over the past 2 days. I think we've had the best part of 40 speakers. We've had audiences who have been really engaged. So thank you to everyone for coming, and hopefully see you all soon.